Okay, welcome back to the next part of this presentation. And now we talk about what is machine learning. So, machine learning is, you can say simply, a study of algorithms that improve their performance at some task with experience. That is a simple thing. What machine learning is that we will look for certain algorithms. So, there might be various algorithms which we can use for this particular problem. But what is the common objective? The common objective is to improve. So what learning does, as I have given you many examples from human beings. So whenever we learn certain thing, for example, driving, it takes time, but what will happen with the passage of time? Our driving skills improve. In the beginning, we just start for the first time in a ground. There is no road. Okay, then we try to learn how we can control the speed, how we can change the gears, how we can manage a lane, how we can turn, and then slowly and gradually, what we do, we learn with the passage of time, and that experience help us to bring that car on the road, and then even after some time you will be able to drive it on in the downtown as well. So how this will happen? It means that you have improving your performance at the same task with experience. So as so if if you have more experience, then you will do good. For example, you want to learn a chess. So as much as you play, you will improve yourself. But remember one thing: as much as you play with the same opponent, you will not learn after a certain time. So it is also important to, for example, if you talk about chess, you have to improve the situation in which you played at chess. For example, you improve your opponents as well. Similarly, driving. If you always drive in a ground, you will never learn. So in the first step, you drive in the ground. Second step, you come to the empty road or the road where you do not have a rush, and then you proceed to the next level, then the next level. So if you do not know the driving and you just take your car and you go to for example, the downtown of the city, then definitely you will hurt yourself, you will damage your car, might be, and this is not a wise decision from any human who has a wise mind. So that is what that is in small, or we can say that this is machine learning or ML. Optimize a performance criterion using example data or past experience. So there are two possibilities: either you have the data with yourself, with the help of data you can optimize the performance. When I say an optimize a performance, it means optimization itself is a minima or a maxima problem. Whenever we apply the optimization function, it means either you are interested to find out the minima or you are interested to find out the maxima. So here, what you want to optimize the performance criterion, and that criterion is set according to the problem. For example, I have discussed about the classification of apples in a factory. So there the performance criterion is the selection in the right bin. So how much selection is being done in the required bin? Let's suppose 99% correct. So it means that is good output from your, let's suppose, from your algorithm which you have applied to it. But let's suppose if it is 92%, then it is not good because 8% is not in the right bin. So optimization itself is of any, if you talk about any particular performance criterion, it is also based on the problem where you have applied it. For example, we just talked about driving. What will be the performance criterion in terms of driving? in terms of driving, in my opinion, the performance criterion is, for example, safety, for example, the traffic rules, okay, and the other things as well. These are what? These are the performance criterion. Let's suppose if you have you have designed an unmanned vehicle which also is there on the roads, and and let's suppose if it hit the people, it hits the car and will not obey the traffic rules or the traffic lights, then in this particular situation, in terms of performance criterion, then it is not optimal. So performance criterion is, for example, we talked about a game, chess game. Here the performance criterion will be the success rate. So how many times you have succeed over your opponent. For example, if you apply the same thing in search-based problem, if you apply the same thing with the search-based problem, there the performance criterion is that how quickly you reach out to a particular node. So in the machine learning problems, the role of statistics is very, very important, because the statistics gives us various mechanisms, various tools, various methods which can be applied to the problems, whatever the problems we have, and we can we can come out with various kinds of inferences. For example, from stats, we can apply the regression models, maybe. From stats, maybe we apply the inference algorithms, that is not exactly from stat, but is from logic. And we can apply the probabilistic based modeling approaches. Uh, Obviously, that also comes under statistics, and there are other solutions as well. So we can make inferences from a sample which is there, and those inference mechanisms can help us to make the decision. Role of computer science: efficient algorithms to solve the optimization problem. So what is the role of computer science? To come out with algorithms, efficient algorithms, so we can devise such algorithms to solve our problem. That is called the optimization problem. That might be, let's suppose you have used a hill climbing algorithm. So hill climbing algorithm again is an algorithm which is classified as an optimization algorithm. And let's suppose you apply for other algorithms such as genetic algorithm. Again, it's an optimized algorithm, gives you the best possible output in terms of maybe the team or the group of nodes, etc., etc. So here we can use the optimization, solve the optimization problem, representing and evaluating the model for inference. We can also represent and evaluate as well the given model for inference, whether it works well, whether it works correctly or not. So we can have procedures to validate it, and we can use it for our problem. So the growth of machine learning is based on various approaches of machine learning. Some of the approaches leads to, or you can say, is preferred in, for example, natural language processing. Because in a natural language processing, it is always difficult to make such applications, because in natural language we have lots of annotations. Similarly, in speech recognition, to identify the speech and translate it, let's suppose, into a text, or let's suppose into a form where other person can understand. So natural language processing itself, computer vision, how we can introduce vision into the machines like human do. Whenever we enter into any specific building, we exactly know how we have to proceed, what are the obstacles there, where are the exits, where are the doors, how to open those doors, where are the stairs, how we can move about these stairs. So we know exactly wherever we go, there is no need to see the map. We know exactly how to proceed based on the given data or circumstances. So how that vision can be introduced into a machine, where machine can process lots of things. So when we see from our eye, we do not only see from our eye, but instead by only looking into a certain environment, we process lot of information. For example, how many people are there, how many objects are there, how many at much distance we are from the others. We lots of things. Lots we can identify the colors. We can identify the people. We can identify various objects. Okay, so we have lots of information which we process while we see. Even when you drive, you see ahead, and by looking ahead, you can process lot of information. That how I have to drive. Can I drive fast? Can I make an overtake? Can I slow down? Can I make a break? So this is what we can see, and that is through your vision. So that information processing can be introduced in a machine, so that machine can do the same task. Medical outcome analysis, this is one area where machine learning is being used a lot. That how we can make the medical outcome analysis. Maybe the people who are dealing with, let's suppose, the diabetes, people who are dealing with, let's suppose, the heart diseases, the people who are dealing with some sort of mental illness, so on and so forth. So on the maybe the MRI images of the brain, lot of people have worked on it. So that is one area, and there are so many other areas nowadays. Now it is being used, and not only with the data we have, but also lot of people are use medical sensory devices to collect that data from humans. Robot control, of course, that is one thing which is also preferred in terms of ML. And then computational biology, because when we talk about computational biology or bioinformatics, it means the area where in the field of biology, where we understand, for example, the chemical reactions going on into a human body. Let's suppose we are interested to know the physiological behavior, or we are interested to know the enzymes reaction, or for example, the protein cycle within a human body. So all of these things have a certain dynamics, and that dynamics can also be represented in terms of machine learning once we have the data with ourselves. So this trend is accelerating. Now what trend is accelerating? That is, the machine learning algorithms are now improved. So we have the improved machine learning algorithms. Why it happens? Because we have a very strong tools nowadays available. We have new approaches to machine learning is available, and that helps a lot to make such systems. So we have improved data capture nowadays. So we can have data capture, networking. We have faster computers, fast networking. We have very intelligent cameras nowadays. We have data, all sorts of data all around the world, and that data capture is no more a problem. Software is too complex to write by hand. So why this trend is accelerating? Because writing a software is a difficult task. So people are learning the ML traits, and they are using various tools for that purpose. So there are powerful tools which are there. So which are not like classical tools or classical languages where we have to write lots of code and then we execute it. So with a small code construct, we can do a big task. Now, nowadays, a new trend is that body sensor devices or sensory devices have been introduced, or IO devices have been introduced all over the world. So now, the what is happening with such devices? Because such devices can be used with certain objects, and they can generate the data. For example, if there is a patient who has some problem in breathing, so they have a sensory device which is attached to that patient, which gives data on the real time that what is the situation of breathing in that particular individual, so that he or she can be given a medical treatment, and that data is coming into the system. So we can generate such a data from lots of people, and then we can come out with trends, and and to find out the related information, and we can use it to fix that particular problem. That sensor based devices can be used even with items in a store. That sensory devices can be used in distribution system as well. Demand for self customization to user environment. Uh, so it means we can also customize the user demands. Let's suppose the user says, I want to have that data to be represented in that manner. So it can be customized as per the user requirement, as per the given environment. It tends to be difficult to extract knowledge from human experts. Failure of expert systems in the 1980s. Uh, in the beginning, it was difficult to extract knowledge from human experts because human experts can have that knowledge with with the passage of time. They interact with the people, they study, they have experience, they have expertise, they have certifications, okay, and then they become the experts. Let's suppose take an example of a doctor who is expert in a certain area. So he went to a medical college. He or she spent maybe 5 years. Then he spent some time as practitioner in a particular hospital. Then they go for practice. Then they go for their higher level recognitions, and then after maybe 10 years, 15 years, they are in a position to say that they have an expertise in that particular area. And if we people from computer science background or software engineering background, if we want to develop such an application which is the expert application, then how this is possible that we can achieve this expertise in maybe 2 days, 10 days, 15 days, or a month or 2 months. So it is always a difficult process to extract the domain knowledge from the people who have expertise. But fortunately, now we have some methods, approaches, which can really help us to extract that information from those experts, which can be used to solve that problem. But the good thing is that this process is a continuous process. So we have a continuous input to the system, which help us to mitigate the problem. So where are we? We have various applications, which includes the association analysis, which we will discuss later on. Supervised learning, which includes classification problem, as I discussed that you want to classify the various kinds of consumers. You want to classify the various kinds of products. You want to classify the customer on the basis of their credit rating. You want to classify any concept, such concept. So we need classification. Classification help us to simplify the problem. So once we classify it, then it is easier to resolve it. Regression and prediction. This is one other area which is comes under supervised learning. So we try to develop the regression curve so that we can know what will happen in the future. So, but for regression, we have to have some data with us, past data with us, so that we can apply the regression model. Similarly for production, and then we talked about unsupervised learning approaches and reinforcement learning approaches. So with this, I conclude over here, and my next talk will start from the same topic. Thank you.